I want to start by taking us back to the year 1860. We are in Buffalo, New York. It's a cold winter day in February, and the wife of George Hollerith has just given birth to her son, Herman. Herman spends his early childhood in Buffalo, and he enters the City College of New York in 1875. He wasn't like the other young people in Buffalo and in the state of New York. He graduated from Columbia University with an engineer of mines degree in 1879. And then at age 19, in the year 1882, he takes a job at the Massachusetts Institute of Technology, where he teaches mechanical engineering. Now, about this same time, the U.S. Census Bureau is gathering information from the 1880 census. And the problem is that it's the early 1880s, and they still don't have all the information that they need about who lives in the United States, what their ethnic background is, where they work, where they worship, all of this important information that they want to gather through the census. And as a matter of fact, they don't know the results of that census for another 8 years because it took them that long to tabulate the data. 8 full years. In fact, they're almost ready to start the 1890 census. And the U.S. Census Bureau realizes that they can't take another 8 years to tabulate that data. Enter Herman Hollerith's electric census machine. Now, Hollerith's machine didn't take 8 years to tabulate the data from that census. It didn't even take 8 months, or for that matter, 8 weeks, or 8 days. Hollerith's census machine tabulates the data from the 1890 census in 5.5 hours. And so begins what we call Moore's Law, where our ability to process information by non-human means, the pace at which we can do that, doubles every 12 to 18 months. And that's not something new. That's not something recent. That is a phenomenon that goes all the way back to the 1800s. And it has changed everything. I want you to take a look at the picture on the screen and think for a moment about what that is. And you realize that that is an iPod. And in fact, it's an old iPod. And it's not just any iPod. That is my iPod. Do you know what I wanted more than anything for Christmas of 2004? I wanted an iPod. Do you know what I got for Christmas 2004? I did not get an iPod. December 26th of 2004, what did I go out and buy myself for Christmas? An iPod. I love that iPod. I had over 7,000 songs on it. I even had that little radio transmitter that you could stick in the top of it and transmit to the radio in the car. It was amazing. And that thing could play music. You know what else it could do? Nothing. The only thing that my iPod could do was play music. Now fast forward 15 years and think about all the things that our smartphones can do, all of the things that our smartphones have replaced. They have replaced our cameras and our calculators and our flashlights and our gaming devices and our credit card scanners. And they have replaced our video players and our alarm clocks and our calendars and our Rolodexes and airline tickets and credit cards. All of those things have been replaced by our smartphone. Think about the world of technology that we live in, this world we call the exponential economy, where products are doubling in price performance every 12 to 18 months because you know what? Adjusted for inflation, all of those things that our smartphones do cost about the same as that iPod cost me in the year 2004. That's the exponential economy. That's what it means to double in price performance every 12 to 18 months. Now think about this. In 1 minute in technology, there are 1 million Facebook logins. 18.1 million texts are sent. 4.5 million videos. 390,000 apps are downloaded every single minute. 87,500 tweets. 1.4 million Tinder swipes, God help us, happen every minute. 188 million emails, 180 smart speakers are shipped by Amazon every single minute. 41.6 million instant messages are sent. 694,000 Netflix hours of video are viewed. 3.8 million Google searches take place. 300 hours of video are uploaded to YouTube every single minute. And almost $1 million is spent on the internet every single minute. In the 60 seconds that it took me to read what is on that screen, all of that happened on the internet. And what's more amazing than where technology is where it's going. Would you believe that in the next 5 years, we will completely eliminate all waste from our food chain using technologies like digital twins and blockchain? Would you believe that in 5 years, our cell phone will be able to detect foodborne pathogens in the food on our kitchen counter using technology embedded on the phone itself? Would you believe that within 5 years, we will virtually eliminate plastics going to landfills through advancements in materials technology? Folks, these are not predictions of mine. These are the predictions of one of the largest companies in the country and in the world, IBM. Toward the end of last year, I was in a meeting with a gentleman from New Zealand, a futurist, who said that in 12 years, we will produce 200 times the world's energy requirements using solar energy in 12 years. So the fact of the matter is that we are in a long period of increasing prosperity as more and more segments of the economy enter the exponential economy. Now, I want you to think about and remember the exponential economy because we are going to come back to it, and that concept will pervade the entire discussion we have today. Because the truth is that the exponential economy has led to what we call the fourth industrial revolution. Now, every speaker on Industry 4.0 has their Industry 4.0 slide. I am no exception. Here's mine. The whole idea of Industry 4.0 is that we are on the verge of the fourth industrial revolution. The first one started in the 1700s, the first industrial revolution with the advent of mechanization and steam power. And then in the 1870s, we started using electricity and mass production and the moving assembly line. And that totally revolutionized between then and the early 1900s the way that we manufactured product. The third industrial revolution took place in the late 1970s and the early 1980s, where the internet and computers and the use of robotics in manufacturing started revolutionizing and did revolutionize the way we manufacture products. The idea is we are on the verge of the fourth industrial revolution, where technologies like interconnectivity and machine learning and digital twins and cyber physical systems will again revolutionize the way products are manufactured across the globe. Let me give you an example of Industry 4.0. Right now, today, General Motors has 15,000 robots that they have deployed across their manufacturing plants, doing things like manufacturing automobiles and moving material and painting automobiles and so on. And they've loaded those robots up with smart sensors and smart devices that are gathering data in real time about things like torque and temperature and disturbances and viscosity and moisture, and sending that data to a computer network that in turn sends it to a data collector that sends it up to the cloud where it is analyzed. Right now, today, General Motors has those robots to the point where they will predict their own future failure and order their own replacement parts before the failure ever happens. And that's that is true not just of robots. It is true of CNC machines and automated weld cells and any automated manufacturing cell that we can dream up. And it's true not just in manufacturing. That technology is alive in healthcare, in agriculture, in distribution, in hospitality. When you think about in my days of manufacturing, I spent 20-some years in the world of manufacturing. We needed to know this stuff, this base technology. And you could be successful on the plant floor. Today, people working in manufacturing, and tomorrow, people working in manufacturing will have to know about smart sensors and smart devices. They'll have to know about control systems and connectivity and networking and data science and data analytics. It is a whole new world of manufacturing, this world we call Industry 4.0. I first got interested in this technology on a trip to Japan several years ago. It was a great trip. I saw the Japanese Disney World. I went to the Shinto temple, saw these beautiful cemeteries carved into the side of mountains, went to wonderful parks, spent time shopping. I even walked by this menswear store. I have no idea what that translates to in English, but I am not about to try to pronounce it for you. Nor did I try the world famous ice cream burger. I did go to the top of the Tokyo Tower and I did try the green Kit Kat bar. It was a great trip to Japan. I even had these business cards printed in Japanese, realized about halfway through the trip that I had entrusted my entire professional reputation to some guy that I met on the internet and paid $50 to translate my business card into Japanese because, to be honest with you, I had absolutely no idea what that said. But what I saw in Japan forever changed my way of looking at manufacturing. We were at the base of this mountain, Mount Fuji, in a 300,000 square foot manufacturing plant on an 18 million square foot manufacturing campus. And we went into that 300,000 square foot plant and I saw these gigantic machining centers like the one up in the upper right hand corner of your slide. And you could fit maybe 4 or 5 of them in a typical manufacturing floor. They were absolutely huge. And I saw these automated guided vehicles that were picking up materials and giving it to robots. And the robot would feed it into the machining center. The machining center would give it back to the robot, and the robot gave it back to the AGV that took it on to the next operation. 300,000 square foot plant operating 24 hours a day, 5 days a week with 12 people. And then we went about a half a mile away. We could have been half a world away, and there was a gigantic screen that tracked that entire manufacturing operation, every machining center, every robot. And as we were standing there, the person doing the demonstration pressed on one of those icons, and a screen came up. And it showed for that particular piece of equipment its cycle time and its performance to standard and its performance to demand, and when it needed to be maintained next and when it was maintained last. And while we were talking, one of those icons turned red and a screen came up and it showed that the line was down. It showed how much lost production had taken place as a result. It tracked the suspected root cause of the line down. And as we were standing there, a video camera came on and one of those 12 people responded to that line down. Folks, I had been in manufacturing for 20 some years. I ran cutting edge, advanced manufacturing companies. What I saw in Japan 4 years ago absolutely blew me away. That started this fascination with Industry 4.0 technology. As Ray mentioned in the introduction, I've had the pleasure for now about 15, 16 years of writing the monthly leadership columns for Production Machining and Products Finishing magazines. I've written extensively on Industry 4.0. About 2.5 years ago, we drafted a white paper teaching the industrial Internet of Things, preparing students and learners for Industry 4.0, became the de facto platform in many, many places for how we think about training students and learners for this new world of advanced manufacturing. The M7, the 7-county economic regional development engine in southeastern Wisconsin, adopted the platform in that white paper as its platform to ready the entire area in southeastern Wisconsin for the coming of Industry 4.0. So is this just a buzzword? Is this just something that people like me get up and talk about so we have something to say so that we can get people excited about technology? Well, let's think about that for a moment. Not long ago, I did a presentation to all of the technical college deans in the state of Wisconsin. And we talked about what is changing in manufacturing that the deans should know about. Rather than coming up with my own list, I went to the experts. I talked to manufacturing CEOs all over the Midwest. And here's what I heard. When I said, what is one trend in your business that technical college deans should be aware of? My friend Bob Venable, President and Chief Operating Officer of Charter Manufacturing, talked about smart manufacturing and Industry 4.0. Todd Wanek, CEO of the largest furniture manufacturer in the world, Ashley Furniture Industries, talked about how his team is so busy automating processes that they can't do them in series anymore. They have to do projects in parallel, fast sprints where they execute really quickly and move on to the next project. My friend Randy Glady talked about having a team of people on his team that just do automation. So when the HR team can't find somebody to fill a role, they have an automation team that can figure out how to keep their plant running by automating that particular operation. Louis Gentine, CEO of Sargento, talked about looking at artificial intelligence for prediction in their business. My friend Mike Chico, President and CEO of Fanuc America, the largest robotics and CNC manufacturer in the world, talked about robotics, controls, and the industrial Internet of Things, aka Industry 4.0. Tom O'Reilly, Vice President of Global Business Development for all of Rockwell Automation, talked about the fact that we need to have learners that know not just the device level, not just what's happening on the shop floor at the manufacturing operation, but everything all the way up to the enterprise level, all the way up to our ERP and our MRP systems that we use to run our manufacturing operations and everything in between. My friend Bill Berrien, CEO of Pindell Global Precision, talked about his foray into Industry 4.0 like continuous machine monitoring. My friend Rick Anderson proving that this isn't just about manufacturing. He's the CEO of Smart Choice MRI, talked about their use of machine learning and artificial intelligence in their business. And Tom Leingarber, the CEO of Cummins, talked about electrification and IoT and telematics, the coming together of the industrial Internet of Things and electrical technology and automotive technology as factors that were affecting the future of his business. Folks, if Industry 4.0, if Industry Infinity 0.0 is just a buzzword, it is a buzzword that is in the minds of every single CEO, every single leader of every single world-class manufacturing company. It is not just a buzzword. So that's Industry 4.0. And now we have consultants and gurus telling us that we have Industry 5.0, the fifth industrial revolution, where humans and robots are working together, or Industry 6.0, which is the reshoring of manufacturing back to the United States, or even Industry 8.0, which apparently is drug paraphernalia painted on the back of a skateboard. Go figure. I see it a little bit differently. I don't think there will be a fifth industrial revolution or a sixth, or for that matter, a drug-induced eighth industrial revolution. I think that we are in a period of continuous industrial evolution thanks to the exponential economy, where we are continually improving, where we are continually innovative, where there won't be another step transformation, there will be continuous transformation. The whole idea of Industry Infinity 0.0, we published this last summer, the new Industry Infinity 0.0 era, continuous industrial innovation and revolution, technologies inside and outside of industry converge to create data and technology-driven manufacturing methods and processes that we never could have previously dreamed. I thought it was an interesting idea, as Dean Kakari mentioned, so did Google. That actually showed up in their regular update of Industry 4.0 technology in their weekly email to their subscribers. So they picked up that article, as did the IIoT report. By the way, if you're not following the IIoT report on Twitter, that is a Twitter feed worth following. Constantly pushing out more and more information about advanced manufacturing, Industry 4.0, Industry Infinity 0.0. Would strongly encourage you to follow the IIoT report. So now let's talk about some technologies inside of Industry Infinity 0.0. What are these technologies if we're not familiar with them? Where are they going? And we are going to start with smart sensors and smart devices. Every one of you has a smart sensor or a smart device. It's probably sitting on your desk. Hopefully you're listening to me and watching the webinar and not texting on your smart device, but every one of you has one. Our smartphones are smart devices. And in the same fashion that the robot company uses those to measure things like torque and temperature and humidity and disturbances and viscosity, those are the same types of smart devices that all of us are using in our daily lives, and we'll talk about that. What makes a smart device or a smart sensor smart? I owe this definition to my friend Greg Chapman at Gateway Technical College. Number one, they can communicate with other devices or networks. And number two, they have embedded intelligence. They can make decisions on their own. Smart technology, smart sensors and devices are what allows some people's car to park itself. You've all seen the commercials if you don't have a car like that. Or the ZFTRW Prevision Cloud Assist that allows our car to know its way home, even if we're not paying attention. That speeds up in areas where we would normally speed up, that slows our car down in areas where we would normally slow down. That is that technology. Or the Bosch Telematics e-call plug that we plug into our dashboard and it can track our car anywhere that we go, knowing exactly where we are, whether we've accelerated too quickly or slowed down too fast. or cornered too fast, gathering all of that data in real time. How about the Bosch Transport Data Logger? If you work in logistics, if you work in manufacturing and you're shipping a $30,000 order somewhere and it gets to the destination and it is damaged, and you call the shipping company and you say, I need my $30,000 back. They just write you a check for $30,000, right? Doesn't exactly work that way. This data logger will track a container anywhere in the world and know where it went and what the temperature was and what the humidity was and whether it got wet or whether somebody ran into it or set it down too hard. All of that data in real time. We have smart sensors and smart devices in manufacturing as well, photoelectric sensors, sensors that can tell us the distance or the absence or the presence of an object, but they do it in a smart way, having embedded intelligence and communicating to other sensors and devices, or pressure sensors or vacuum sensors. Ultrasonic sensors or photo eyes. Who among us in manufacturing doesn't know what an on-down light or a stack light is? Most of them require a signal from somewhere else. How about a smart stack light that can make its own decisions based on the data that it's gathering itself and produce its own signal? So smart technology, smart sensors are alive and well in manufacturing, and we'll be talking about that. These devices, they exist on the edge. When you think about somebody calling something an edge device or an edge sensor or edge computing, that is what we are talking about, all these smart sensors and smart devices that exist on the edge. They communicate when they need to the fog. Our computer networks, our data collectors, our programmable logic controllers in manufacturing, which in turn communicate with the cloud, external data centers that are gathering our data and analyzing it. So in my days of manufacturing, the way this worked was you had a dumb sensor, a temperature sensor that would measure the temperature of something, send that signal to a network, to a computer, to a PLC, where it was analyzed, and then sent that back down to some form of an output device. And that is pretty traditional manufacturing. That limited the amount of sensors and smart technology that we could deploy. Why? Number one, because that process takes time. People in the business call it latency. It's microseconds, but it takes a period of time to get information from a sensor to whatever is going to analyze it and back down to the output device. Second challenge is bandwidth. For any of us that are working at home, mom and dad, probably all of us working at home, mom and dad are on the computer network, the kids are doing their distance learning or maybe streaming whatever they're binge watching on Netflix, and we load up the internal Wi-Fi in our house. Manufacturing isn't any different. There's a certain amount of bandwidth with which we can transfer information, and we limit that bandwidth. Now what happens when we take these devices and make them smart? Remember, a smart device can communicate with other devices and networks. It has embedded intelligence. So what happens when all of these, instead of having to send their information up to the network and back down, can communicate with each other? The time and bandwidth bottlenecks go away. And this is part of why smart technology in manufacturing is absolutely proliferating. I want you to think about this example from the world of transportation. About 2 years ago, I was in Japan, and I was driving from Tokyo out to a manufacturing facility with a gentleman that was working on a huge automation project for Lear, the big automotive seating company. And he said, Matt, in the year 2015, the average automobile had 30 smart sensors on it. You know what that number is today? The average automobile that's being produced here in 2020 has over 1,000 smart sensors and smart devices. That is the exponential economy. That's doubling in price performance. That is how this works. Take a look at that picture and think about if you know who that person is. I'll admit that I didn't. Last summer, I got an email from my friend Mark Money, who's the chancellor at the University of Wisconsin-Milwaukee. And Mark said, Matt, I'm having a cocktail event for Brad Smith. Would you be interested in attending? And my answer was, cocktails? Absolutely. Who's Brad Smith? He's actually the president of Microsoft. And here's what Brad Smith had to say about smart technology. He said by the year 2025, 25 billion with a B, 25 billion devices will be connected to the internet. According to him, it's a $2.7 trillion market. Do you think that's a market that Microsoft is paying a little bit of attention to? Not long thereafter, I was in the lobby of this great Wisconsin manufacturer, great Wisconsin innovator, Rockwell Automation. And I was waiting for a meeting, and in walks Dr. John Carrier from the Sloan School of Management at MIT. And John was waiting for a meeting. I was waiting for a meeting. We started chatting with each other. He was really fascinated in the whole private equity world, and I had run a private equity-backed manufacturing company for a number of years. We talked about that for a while. And then our discussion turned to smart technology. And John told me three things that made sense out of this whole world of innovation and smart technology. He said, first of all, we have seen a cost reduction in smart sensors of several orders of magnitude in the last few years. Now, an order of magnitude means that something that's $10,000 becomes $1,000, becomes $100. Take a zero off every time. That's what an order of magnitude is. Several orders of magnitude in the last few years. They are getting smaller. So we can use them in places that we couldn't before, and we can use more of them than we could before. And here's the thing. Today, the cost to buy a smart sensor and connect it to an IoT platform is less than $100. Folks, that is the exponential economy. That is what that looks like in manufacturing, doubling in price performance every 12 to 18 months. And it has been, and it will continue to change everything about the way that we manufacture our products. Let's talk for a minute about informational data and some careers in Industry 4.0. In my days of manufacturing, if we wanted to improve a process, if we had a problem, we would find a group of managers, and we would set those people on the shop floor in a circle, and we would stand around the problem, and we would look at the problem, and we would talk about the problem, and it became really, really clear really quickly that we did not have enough information to be able to solve the problem. And so we would find somebody that we called an industrial engineer, and we would give them a clipboard, and we would send them out to the floor, and they would watch the problem for a day, a week, a month, whatever it took to gather the data, and then we could start to think about improving that process or that problem. Folks, in the world of Infinity 0.0, the problem will not be a lack of data, but way too much of it. And the challenge is discerning what we call informationable data, that data that actually can be used to improve a process. It's a copyrighted term. I own the copyright. And informationable data, and use that to improve our process and discern that from all of the data that doesn't really matter. Here's the truth. Last year, we created more data than we had in the previous 5,000 years of human history. Just last year, according to IBM, 90% of the data that exists in the world today was created in the last 2 years. Not long ago, I was in a meeting with the vice president and general manager of data-enabled solutions for Johnson Controls, the big building controls company. You know what he said? He said if you take all of the likes on Facebook, all of the data from billions of people all over the globe liking things on Facebook, and you add up the amount of that data, that is the same amount of data that is produced by just 300 smart buildings. We are swimming in a world of data. Ask yourself, what is a quant? What is a quant? Have you heard that word before? A quant is actually short for quantitative analysts. These are the people on Wall Street who gather information, who analyze situations, who understand what's happening in markets using mathematical and statistical modeling. There's actually a school called the Stevens Institute of Technology in Hoboken, New Jersey, that trains people just to be quants. Here's a young man, Dakota Wixom, who graduated from that program, quoted in Forbes magazine. He said, you can't just buy growth stocks anymore and expect them to outperform the market. It becomes a data science problem. There are hundreds of hedge funds, and only a handful of them generate alpha, meaning only a handful of them beat their market averages consistently. How do they do it? They hire quants, they hire data scientists, they hire programmers. My friends, that same level of innovation, that same level of data analytics is coming and is already in manufacturing. If you are someone you know is smart and analytical and hasn't decided on their career, there's a huge opportunity for those that understand manufacturing or retail or hospitality, healthcare, agriculture, building the tools to gather and analyze information to create that informationable data. I have a child who's a senior in high school, graduating next month. What do you think her career choice and what do you think she is pursuing in terms of the next step in her education? And the reason is there are awesome Infinity Point oh careers. There are awesome careers in these areas of technology. About a year ago, Manpower wrote a white paper along with some other folks called The Digital Workforce. And in it, they go through the opportunities and the career opportunities within advanced manufacturing. Now, the white paper gets into a little bit too much edu-speak for my taste, to be honest with you, but there is some really, really interesting information. These are the types of careers that white paper contemplates in manufacturing. Cognitive system scientists, virtual and augmented reality system scientists, manufacturing cybersecurity analysts, collaborative robotics specialists, instrumentation engineer, predictive maintenance systems specialist. The challenge is most of our young people have no idea that these careers exist. Would you believe that automation engineer, according to USA Today, is the 4th happiest job in America? How many young people know that that is a job they could even have? And this isn't just manufacturing, as we suggested. It's healthcare, it's transportation, aerospace, retail, agriculture, hospitality, financial services. Data analytics is becoming a huge part of every one of these economic sectors. Think about this. According to the Future Farmers of America, the top 5 agricultural careers include things like drone technologists and precision agriculture technologists. Top 10 future healthcare jobs to watch according to Forbes: 3D printing specialist in healthcare, robotic clinical documentation, precision medicine pharmacist, neurostimulation specialist, and data hacker. And when it comes to the world of automotive, according to Autocar electrical engineer, analytics expert, interaction designer, autonomous driving engineer, 3D printing, there it is again, and alternative propulsion engineer. The careers available to our young people in the future will blow us away. We need to get them excited about what those careers look like. Let's talk for a minute about digital twins and artificial intelligence. Let me ask you this question. What is opinion, size, age, shape, color, origin, material, and purpose? That is the order that you, without even knowing it, place adjectives before a noun. Which is why if I say lovely little old rectangular green French silver whittling knife, it might sound a little weird, but you can picture what it is that I'm talking about. But if I say old little French whittling lovely silver rectangular green knife, I sound like I'm crazy. It's why we can't say things like my Greek fat big wedding, or my walking leather brown boots, or green little men. What is IAO? IAO is the order in which you, without even thinking about it, place similar sounding words based upon their vowels, which is why it's really hard for me to say mash, mish, chat, chit, dally, dilly, shally, shilly, top, tip, hop, hip, flop, flip, tack, tick, and dong, ding. But I can say mishmash, chit chat, dilly dally, shilly shally, tip tap, hip hop, flip flop, tic tac, and ding dong really, really easily. When you think about even how we speak, you get an idea for the challenges that data scientists, people that build algorithms, people that build artificial intelligence, the challenges that they have in figuring out how the human brain works. But they're making progress. Not long ago, I saw this demonstration. It's actually a robot painting a fuel tank. Now, I worked in that business for a number of years, built fixtures for holding fuel tanks, came up with ways to remove coatings from fuel tanks, help people automate fuel tank painting processes and other painting processes. So I saw this demonstration, and I started talking to the engineer that put it together, and I said, wow, you know, that is really impressive. He said, if you think that's cool, you should see this. And we walked across the aisle, and he had a computer simulation running, and it looked like this. And it was a simulation that was identical to what I was seeing in the manufacturing operation. That is what we call a digital twin. How many of you know that NASA actually has a Center for Advanced Manufacturing? I actually partnered with them a number of years ago when I was building a material handling solution along with my team for handling material within a huge motorcycle manufacturing operation. So we partner with NASA. We partner with their advanced manufacturing folks. Here's what they say about the digital twin. John Vickers, who's the director of that program, says, the ultimate vision for the digital twin is to create, test, and build our equipment in a virtual environment. And it isn't until we get that virtual version of the equipment working exactly the way that we want it to that we try to build the physical manifestation of that same process. Only when it's working perfectly do we create the physical manufacturing operation. Here's why that's important. If you think about this process and you think about the process of painting a product or manufacturing a product, one of the scariest things to anyone in manufacturing is having to change the process. If you come up with a process improvement, it is a scary thing when you have to implement that process improvement, because if it doesn't work, it's all on you. But now we take that process and we load it up with the smart sensors and smart devices that are gathering all of the data that we talked about before. And then we build our digital twin that mirrors exactly what's happening on the manufacturing floor. And when we go to make an improvement to the process, we don't start here, because we have loaded this thing up with smart sensors and smart devices, feeding data back to our digital twin. Our digital twin gets smarter and smarter and smarter over time, and we make the change here. And we see what happens. And we fix any undesired outcomes before we build the manifestation of that change on the manufacturing floor. I want you to think about artificial intelligence as it associates and as it ties to the digital twins and otherwise. 69%, according to MIT, of executives believe that their industry will be completely transformed by artificial intelligence by the year 2022. Firms that invest in human-machine collaboration could grow, according to MIT, their revenues by an average of 38% by 2022. And in a survey of 1,500 organizations that they reviewed on the topic of artificial intelligence, here's what they found. Number one, while AI will certainly eliminate jobs, it will also create a lot of good jobs that leverage human capabilities in different ways. It's one of the most popular questions I get when I talk about Industry Infinity 0.0 is, what's going to happen to all the jobs? Isn't it going to disrupt the workers? The answer is, of course it will. But will create tremendous amounts of opportunity within the manufacturing space as well. MIT sees three different opportunities within artificial intelligence when it comes to career choices, and I want us to think about these. Number one are trainers. These are the people that are actually creating the data science algorithms and the machine learning engineering, actively building AI. That is a whole host of career opportunities. Number two are the explainers, people who explain to people like you and me exactly what AI is doing, how it's working, what kinds of outcomes it is generating. And finally, because the social conscious side of this stuff is so important, we have the sustainers, people who make sure that artificial intelligence not only behaves properly, but continues to produce the desired outcomes over time. Trainers, explainers, and sustainers, great opportunities within the world of artificial intelligence. So now let's talk a little bit about what all of this means for education, because education is certainly adapting to the world of Infinity 0.0. And I like to start this discussion by talking about what influences a young person's career pathway. Think about that for a moment. What influences a young person's career pathway? Maybe you have a list in your head of 2 or 3 things. Maybe that list looks somewhat like the conclusions that were drawn by a study done by Skills USA and the Manufacturing Institute not too long ago. Things like fathers and mothers and teachers, friends and classes in other media. These are the types of things that influence a young person's career pathway. But you know what that study found? There's one other influencer that is 3 times greater than any of the other items on that list. 3 times as influential in a young person's career pathway. And that is their own interests and experiences in middle school and high school. And that's why if you walk into your middle school, if you walk into your high school and the technical education program doesn't look like this, that's the reason that your manufacturers can't find people, is that we are not inspiring young people toward careers in advanced manufacturing and careers in technology. Gateway Technical College, of course, is doing a great deal to try and change this, and they're having a tremendous amount of success. They introduced 4 courses as part of their advanced manufacturing technology degree about 1.5 years ago. Introduction to mechatronics, controls, robotics, and IIoT. And today I'm happy to say that over 72 high schools between Minnesota, Wisconsin, and Michigan are teaching those competencies in some way. Teaching students about introduction to mechatronics, fluid power, and electrical systems, and mechanical drives, teaching them about industrial control systems and programmable logic controllers and CNC controllers and variable frequency drives, teaching them about robotics and robotic safety and jogging and branching and programming, and teaching them about IoT, smart sensors, smart devices, connectivity, networking, and cyber security. 72 high schools across those 3 states. And you know what? It's working. This is one of my favorite articles from last year. It's about a young man named Jaron Ramig. I'm not going to speak for Jaron. We'll let him speak for himself. Let's read this quote. These classes have been a great stepping stone for me. When I get to college, I will have half a year of my degree already done. Since I didn't pay for those classes, I'll be saving money, and I'll end up having to pay about $6,000 to earn a degree in a career field that I can earn $60,000 to $80,000 a year. That's a great investment of my time and money. Tell me that Jaron Ramig doesn't get it. Here's another great example. This young man's name is Kyle Pike. Kyle, about 1 year ago, not quite 1 year ago, graduated from Lamira High School. He took a 1-semester course in basic robot operation and programming in a program that was sponsored by a company called Metalcraft of Mayville. Graduated in June of last year, and the day after he graduated, he started a job as a robot programmer 1 day out of high school, working for Metalcraft of Mayville, a 1-semester course in high school. Now, I don't have any idea what Kyle makes. It's none of my business, but I can tell you that those types of jobs start in that range of $60,000 to $80,000 a year. Not bad for a 3-credit course in high school. And here's the thing. His employer will pay him to continue his education at the technical college. So that is not the end of his education. That is the beginning for Kyle. Things are alive and well at Gateway Technical College as well. Let's show you some examples. This was the reopening of the IMET Center back in the month of October of last year. Remember when we talked about what we saw in Japan, that the robot loading and unloading the machining center? That's what it looks like on Gateway's sim system. Remember when we talked about the AGV, the automated guided vehicle, and the technology that would pick up the material and take it from machine to machine with no human involvement? That's what this looks like at Gateway Technical College. Students learning about the technology embedded in an AGV, how to program it, how to utilize it, how to put it to work. Remember when we talked about putting all of this system together, talked about smart sensors and smart devices? Well, there's that technology at Gateway Technical College, where students are learning about smart technology and programmable logic controllers and robotics and variable frequency drives, and all of this technology buried on a smart manufacturing system. And finally, remember when we talked about the data analytics side of this? Remember when we talked about being able to track in real time what was happening on the manufacturing floor? The signals that showed us what our cycle time was or our performance was or whether we had a line down? That's what this looks like at Gateway's IMET Center. Really, really innovative ways to teach smart technology and smart manufacturing. Other examples throughout the state of Wisconsin. I was at the grand opening of the Computational Science Hall at MSOE last October, doing some really great things in the area of computing. I know my friend Mary Bunzel, who's the executive director of the Connected Systems Institute at UWM, is on board with us today, doing great things in terms of connected technology and smart manufacturing. Our friends at the Data Science Institute, a collaboration between UWM and Marquette University and Northwestern Mutual Life. In UW-Madison now opening up a program and an emphasis on computing and data analytics. How about this example from Wayne State? Some of my colleagues worked on this last year, drone technology. When we think about teaching drone technology, our brains immediately go to how do we fly a drone? Well, that's interesting without question, but what about how these drones communicate with each other? How about how we make a flying drone and a ground drone communicate in real time? How do we learn that swarm technology that we all saw when the Olympics put on that amazing show during the opening ceremonies about a year and a half ago, with drones avoiding collision and all talking to each other? How do we teach that technology? This technology will be alive and well in the world of Industry 4.0 and Infinity 0.0. How do we teach it? And then my friends at the University of Wisconsin-Stout doing great things with the Smart Automation Certification Alliance, having brought employers from all over the state of Wisconsin together to build competencies in Industry 4.0, to understand what is it in Infinity 0.0 and advanced manufacturing that our people need to know in order to be successful, whether they're an entry-level employee, a technician, or a professional engineer working in the world of advanced manufacturing. So we could go on about this technology, cyber physical systems, hardware in the loop, rapid control, prototyping, robotics, automation, and so on. Let's talk a little bit about the importance of lifelong learning. Would you believe, according to Pearson, the textbook company, that 24% of employees say their employers offer zero learning and development? 1 in 4 get none. Only 34% of large employers offer direct courses to employees. And the number one reason employees don't take advantage of tuition reimbursement is that it's hard to take time off. I've got to get the kids to soccer. I'm going to church on Sunday morning. I've got my job during the week. It's hard for me to take enough time off to continue my learning. I can tell you there are some great examples from Gateway Technical College and other technical and community colleges of partnering with employers and showing them how we can train students right on site, train their learners right on site at work, make the best possible use of their time to maximize the way that we move learners through an understanding of Infinity 0.0. Another great example of that is the Advanced Technology Maker Center. That's Ashley Furniture's employee training center in Arcadia, Wisconsin. Take a look at this. These are incumbent employees that take several hours a week using an e-learning platform and hands-on learning to learn skills that are valuable in advanced manufacturing. Here we've got somebody learning how to use a dial caliper and a micrometer, somebody doing a knowledge check to make sure that they've grasped what it is that they were supposed to learn, somebody building a virtual electrical circuit. Here's somebody building a hydraulic circuit, somebody else building a pneumatics circuit. This is my favorite. Took this picture not quite a year ago. I think this gentleman is in his early 60s. He was in the Advanced Technology Maker Center. He was building his own hydraulic circuit there, learning about hydraulics, and I struck up a conversation with him. He was a couple years from retirement, but he said, that's not a reason for me to stop learning the technology that will make me successful in my job. That's what lifelong learning looks like. And guess what? Every one of those students has the opportunity to earn one of those certifications from the Smart Automation Certification Alliance. So now before we wrap up today, and we're a few minutes from doing that, some predictions about COVID. Let's start first with the world of education. Will schools be open in September? This was a headline that showed up this week. We asked several experts to weigh in. Of course, schools will be open in September, especially higher education. We have universities in the state of Wisconsin that stand to lose, in one case, $100 million if schools don't open in September. Another one stands to lose $600 million if schools don't open in September. Yes, our students will be on campus in September. That is my first COVID prediction. But it might not look like the world of education that we left in March. Here's a headline out of the state of Ohio, where their schools are looking at 2-day in-person classes. So you have half of the student body come for 2 days, and then the other half come for 2 days, so we can maintain social distancing. We are learning a tremendous amount about distance learning. Our distance learning, our Virtual simulations have been put in hyperdrive the last 2 months because we didn't have a choice but figure it out. And there are a lot of students that are saying there are some aspects of distance learning that I like a little bit better. We're integrating way more simulation-based learning, not just in healthcare, but in manufacturing. Last week, I worked with a team that published an article about how leading institutions of higher education are utilizing their CARES Act funding, their funding from the federal government that is intended to address the COVID crisis. The provost of the University of Wisconsin-Milwaukee shared this with me. He said he foresees an increase in online teaching as IHEs, institutions of higher education, move to a hybrid model. The new model will integrate in-person instruction and experiential learning, with online content delivery and simulation playing a significant role. That is a 4-year university that has been forced to totally revolutionize the way that it is delivering its learning to its students. It is going to look different in the fall. But hands-on learning will still be incredibly important. I like this headline. You can learn math and English online, but how about pottery? We will have hands-on education. We will have students working in labs. We have to. They have to get on real manufacturing equipment, real healthcare equipment, real equipment before we put them into the actual place of work. And so we will have hands-on learning. It will look different, but we will have it. I want to close this afternoon with this. The red arrow on this slide points to my friend, Bill Berrien. Bill and I recently collaborated, actually this month, on an article for Production Machining magazine, wherein he compares his military service to careers in manufacturing. He compares his time, now get this, as assistant commander of SEAL Team 4 and as commander of Navy SEAL Team 2 to manufacturing. Berrien describes the toughest point of Hell Week, the initial training to become a Navy SEAL. During Hell Week, the SEAL candidate is basically awake from Sunday to Saturday, with the exception of 2 hours of sleep permitted in the middle of the week. He describes it like this. About the midway mark, Wednesday night is the ugliest. As the sun goes down and you're linked arm to arm with your whole class, sitting in the surf zone in 18 inches of cold water. Waves crashing over you and rolling back into the surf. Your energy is at its lowest. Your morale is at its lowest. But I told myself, I'm going to finish this evolution without quitting. I am going to get through this. Folks, I'm not pretending that the current crisis is anywhere near as grueling as Navy SEAL Hell Week, but we are going through our own version of Hell Week right now. We're unsure of the future. We're scared. Some of us may be even thinking about giving up. Now, if you recognize Berrien's name, it might be because he was one of the executives that we talked about earlier in our presentation when we talked about the shift to Industry 4.0. He is now the CEO of Pindell Global Precision, a precision machining company in Wisconsin. Here's what Berrien says about the future of American manufacturing. He predicts blue skies ahead for American manufacturers. He says, I actually think the future of advanced manufacturing is incredibly bright. I think we will continue to see a questioning of the status quo, global supply chain, now that one can see the impacts when it's disrupted. Think about it. N95 masks, disrupted supply chain. Ventilators, pharmaceuticals, disrupted supply chain. We are learning the risks of a global supply chain, and while there will always be a global supply chain and always be global manufacturing, it is coming back to America, closer to the point of consumption. The question is, who among us will benefit? Because it's not coming back the way that it left. It's coming back more robotic, more automated, more reliant on smart technology, and more data-driven than ever before. Manufacturing is coming back Industry Infinity 0.0. Let's make sure our students and our learners and our employees and our communities are ready.